In question 18, we have a solid cone with a radius of 10 centimeters. And there's a smaller cone, radius unknown. Its perpendicular height is 1.5 centimeters. And the overall height for the entire cone is 20 centimeters. So this smaller cone here gets cut off the top, and they want you to calculate what the volume is of what's remaining. So the only way to do that is to get the volume of the entire cone minus the volume of the smaller cone. Okay. So in order to get the volume of a cone, we use the formula 1/3 pi r squared h. Now for the large cone, that's absolutely no problem. So volume of the large cone and sorry, by large cone I mean the entire cone. So that's 1/3 pi, the radius is 10 squared, and then the height is 20. And for that one, you get 666 2/3 pi. Now for the smaller cone, we have a problem because although we know what the perpendicular height is, we don't know what the radius is of the smaller cone. So what we're going to do is we're just going to take a little peep at the triangles that are created inside it. So if you look closely, we have a big triangle running the entire cone, and then there's a smaller portion that creates another right angle up at the very top. So what we're going to do here is we are going to try and calculate what this missing value is here. So we're going to call this R2 because it's the second radius. So we're looking for that. Now we know that the entire cone, or sorry, the entire height of that one is 20. And we know that R1, the radius here, is 10 from our diagram. And we don't know what the large hypotenuse is, this large side here. So if we call that H1. So using Pythagoras' theorem, H1 squared is going to be equal to 10 squared plus 20 squared. So H1 squared is 100 plus 400. H1 squared is 500. So H1 is 10 root 5. Okay. Now, these triangles have a special relationship, okay, because they're based on the same triangle. This is just a smaller version of this. Each of the sides measure at a certain ratio to each other. So what we can do is we can take our two things that we know. Okay, we know the entire height is 20 and that the smaller height is 1.5. So we can take the 20, divide it by the 1.5, and it gives us a ratio of 13 and 1/3. So if we want to find what 13 and 1/3 of the height is, that should give us, sorry, the hypotenuse. That will give us the second hypotenuse here. So we take our 10 root 5 divided by 13 and 1/3, and we get 3 root 5 over 4. So now in our smaller triangle, so this is the top triangle, we have a height of 1.5, perpendicular. Our second hypotenuse is 3 root 5 over 4, and we're still looking for our second radius. So repeating Pythagoras' theorem again, so 3 root 5 over 4, all to be squared, is equal to 1.5 squared plus the second radius squared. So we square that out and we get 2 and 13 over 16. 2 1/4, plus 4 squared. Then we have 9 over 16 equals r squared. And at the end of it all, r equals 0.75. So now, having already calculated the volume of our entire cone or our large cone, because we've now worked out the radius, we can now find the volume of the smaller cone. So that's 1/3 pi r squared h. And that small volume comes out as 9 over 32 pi. So to get the remaining, we have our large volume, 666 2/3 pi, minus our smaller one, 9 over 32 pi. We get left with 666 37 over 96 pi, which is equal to 2093.511529. And the reason I'm doing this is because in the question it asks us to calculate the volume to two significant figures, and I can't do that if I have the symbol in for pi as opposed to the actual figures. So now I've got this exact value, and to round that to two significant figures, so 1, 2, 9 is next, so I have to round up. So 2100, apologies. So 2100 centimeters cubed is the volume of the cone that remains when the smaller cone has been removed.